Well, time is up. It's 11 o'clock. We are starting the webinar. Welcome, everyone. And welcome to Gothenburg. We are broadcasting from Auto Valley, Gothenburg, the home of Sweden's automotive industry. My name is Joachim Hökegård, and I'm going to moderating the webinar, and we are going to email the PowerPoint you are going to see and the presentation, the recording after the presentation. And if you have any questions, you can write them in the comments up to the right on your screen, and we will address them after the presentation. But first, a brief introduction to Diadrom. Diadrom is a software company offering services and products within diagnostics of auto tech, and thereby enable companies to realize and exploit greater potential in their products and services. We work across the entire lifespan of a vehicle, from R&D, manufacturing, to the aftermarket. We have software products and expert consultants to update the diagnostic capabilities and software, ensuring optimal performance and compliance with evolving standards and regulation. But now it's time for me to introduce our speaker, Victor Eliasson, an expert in diagnostic software for the automotive industry. The audience and the camera are yours, Victor.
Oh, thank you, Joachim. You're so kind. Thank you, and all of you out there, warm welcome to our second webinar this year. Last time we had a webinar regarding bootloaders and their importance within the ECU project deliverables. And today we have come to cybersecurity, the future automotive cybersecurity. It's really close. I will let you know in short, but in July there will be a lot of new regulation and standards going into action and impact our business quite hard. So yes, we will take the next slide. The agenda for today, of course, we will go through the background regarding cybersecurity for road vehicles. We will also go through some implication for the same and its electronic architectures and systems. And of course, why do we need to have the cybersecurity in place? It's because of the great buzzword, the software-defined vehicle. And then we will let you have a brief summary of what we've gone through today. So that is the main agenda for today. Yes, great. As I told you before, there will be a lot of new standards and regulation going into action this July. There are mainly two UN regulation, 155 and 56, which are focusing on approval and processes for cybersecurity when it comes to design and construct software for automotives. Moreover, regarding the 156, it's how you deliver a software update, of course, both physical and remote. And this is all the OEMs, but also Tier 1 and Tier 2 able to go through this kind of approval. So it's really important standards going forward. However, there are also a new ISO standard named 21434, which is how you engineer a cybersecurity software for an automotive vehicle. So, and for you all out there, there are also other ISO standards like cybersecurity for IT, ISO 27001, but also one relative automotive standard, which is important, which is named TISAC. It's really important as well in the industry going forward. These standards, someone was quite quick with the slide jockey here. So this applies for UN, as UN is almost the whole world, but we need to exclude both USA and China in these standards because it's only the EU and other additional 58 countries who signed up for these UN standards. That's a good thing to know. Yes, next slide. Managing cybersecurity is now a must, as we said before, regulation and standards. Why? Because there will be a lot of connected cars out there in the roads. In the USA, there are 84 million cars in 2021, but will increase to 300 million cars in 2035. Another big important point here is about 38% of the suppliers and 17% of the automakers have really big issues regarding this new cybersecurity compliance due to increasing cost, but also expertise. And the last but not final ones, the API-based attacks have increased a lot during the years. API, as you know, is connections to other system and processes or software related to the car. And this is increasing due to the connected cars. So it's a really important point here. Due to almost 95% of all the cyber attacks is remote. Next slide. As you can see, previously we only had the car itself to manage out on the road. However, now we're increasingly connecting other infrastructure, other system, other processes to the vehicle. For example, we are connecting the vehicle to the grid. We are connecting to the vehicle. We are also increasing the connected services, backend databases, etc. And we got a new complex automotive world out there. Next slide. So, if we're going down to the vehicle then, which is more or less Diadrom's domain, we have a lot of different attack surfaces going on in the car and around the car. There are both wired hacking opportunities. We have physical layers like USB, etc., but also other attack surfaces like Wi-Fi, GPS, spoofing GPS, for example, but also NFC, etc., Bluetooth, which is quite easy to get a hands on. Yes, next slide. And this is just an illustration how much this market will go up. From 2022, the market will be around $3.2 billion, this market value, but will increase to like $22 billion in just 10 years. Yes. Next slide. So, going into the implications regarding the software cybersecurity related activities. As we all have experienced during the recent years, our OEMs and tier 1 suppliers are really facing big hurdles. And unfortunately, it's not going to end here. It's not going to end with electrification. It's not going to end with the software-defined vehicle. It's going to continue with cybersecurity, and it will cause a lot of headache going forward. Yes, next slide. So, delays and impact. We had several manufacturers and OEMs, which platforms have been delayed. And this, of course, creates a lot of costs, a lot of stress out there, both for the OEMs, of course, and tier 1 suppliers, but also impacting the customers, which are choosing another supplier of cars. Yes, next slide. This is just a brief sum of two news that are facing these new problems regarding cybersecurity. We have the Volkswagen e-up, who will be stopped produced due to this new harder cybersecurity regulation and standards, which is quite new as well, this car. But also premium and luxury cars like Porsche Macan. Why is this then? Because it costs too much money to update the current platforms, so they are retiring those or put to sleep, if to say so, instead of doing that investment in these platforms. And of course, there are some facts here as well, but the last one is of course quite substantial. That NXP says that none is prepared for this. To be honest, the whole complete automotive supply chain is not prepared, and this is quite alarming. Yes, next slide. Going into the concepts regarding automotive cybersecurity. A lot of the cybersecurity related concepts are of course defined by the OEMs, which are put forward to the tier 1 and tier 2s. This is of course based on the new regulations and standards, but there are quite many proprietary concepts out there still. There will be new diagnostic services, for example, to implement regarding diagnostics. There will also be a lot of verification and authentication of software. We will introduce a new secure software download process, which we are using different keys and crypto library. There are also new concepts regarding tamper resistance. For example, if someone needs or trying to download new firmware or middleware into your ECU or car, the ECU will be bricked, and therefore you're not able to drive forward, instead of the hacker taking control of your car. There are a number of different crypto algorithm implementations out there, which we don't have any standard yet. So there are a lot of different out there. And there is also a new physical implementation of this cybersecurity requirements, which is a hardware security module, which is a physical computing device which are only used to process cryptography. Yeah, sorry. Yes, next slide. So this hardware secure module, which is often provided by semiconductor manufacturer like NXP, Renesas, of course, will be a must going forward. So this is built into the microcontrol unit. And this, of course, gives a physical protection that are using ensuring, that we're not able to steal or altering the vehicle software when you're out driving. That's quite a good thing. And this is quite advanced stuff. So this will, of course, add some cost and implementation time for us as a tier 1 and tier 2, but also for the OEMs. Next slide. So this is a more advanced technical slide. However, it's quite important to mention how this works. When we are fortifying an ECU or a car, for us as working with ECU suppliers, do create different keys that are related to this hardware secure module, which we're then providing to the OEM, which is then programming this key, and of course save it on the safe side of theirs. When you are later then receiving a software download or new software, this need to be verified by this specific key. If this specific key is not given, you will not be able to alter it or tamper with this ECU. So this is some really confidential stuff which the OEM needs to be taken care of in separate systems, and also a part of the new regulation. Okay, how do we, next slide. How do we, as a supplier for these cybersecurity concept, handle these variants and different concepts? we tend to develop different hardware abstraction layer, which gives us the freedom to enhance flexibility, giving us the possibility to help our customers to different vendors. We can use NXP's stuff, we can use Renesas MCUs and HSM. And this, of course, will reduce time to market. Also might be helpful if there's be a semiconductor shortage as the corona. But it also will simplify the whole software development project. We also have found a way to standardize integration. And of course, this also minimizes the knowledge you have to have on different cryptographic functions across the different suppliers. Yes, next slide, thanks. So, it's not all good regarding cybersecurity. There are some downsides of cybersecurity as well. As I've been speaking before, it will increase complexity. It will add complexity, of course. You need different software packages. You need to handle keys. You need to handle new processes. And this increases the complexity in the car, of course. However, it will also increase costs regarding bill of material, regarding engineering, of course. We need to have really good documentation. We need to have good processes. We have to have good test and verification. Due to this, regulations states that we need to have maintenance and taking care of these processes for over 15 years. So this will add a lot of cost going forward. But also manufacturing a bill of material. This new software will increase, of course, the cost regarding MCU cost. For example, you need a bigger and greater MCU to handle these new cybersecurity functions. This is, of course, one of the biggest costs for us out there. Another insight from our project is it increase the latency quite a lot. Latency is meaning by the dragging, the signaling is it's much slower, and we need to have better timings going forward and decrease the latency. Yes, next slide. So, cybersecurity and the software-defined vehicle, I think it goes hand in hand due to what the concept is regarding software-defined vehicle. This is also a booming industry. The software market will increase to over 650 billions in the automotive industry by 2030. And in last year, 50% of the top 10 automakers will offer new feature throughout software updates. And another big thing is, of course, people are ready to spend money for new features going forward. And this will open up for cybersecurity threats. Yes, next slide. So, how are we making the software-defined vehicle then? It's quite, if we look at the cell phone markets, many like to compare it. It's quite a simple comparison, but it's quite tangible. We need to decouple life cycle and software and hardware. We need to take software and put it on new hardware. We also need to be able to update hardware as we're going forward. An example is, okay, how would Apple be able to maintain the iOS system? They have done it for a lot of iPhone generations, and therefore they get a scale of economy of scale, etc., and reduce the complexity in their OS development. We need to deliver new value in existing vehicles, of course, and we need to have software updates who adds new feature for us out there who's driving the car each day. And the comparison, of course, to the iPhone, if we wouldn't have the App Store, what kind of value or fun would that be, having an iPhone without an App Store? And of course, the third one is we really need to capture the value of software and data. We, of course, need to make money as an industry from data from the car. And this is also an example from Google, for example. They're not giving away their operating systems for free. They are monetizing it regarding our data and the App Store, of course. So these three must go hand in hand going forward. Next slide. And as I said before, there are a lot of systems and boundaries and mindsets that need to connect. There are, as we see here, there are both cloud services. We both have vehicle computing systems need to control embedded different ECUs software. We also have the mobile and connected services that need to go hand in hand. And this opens up a lot of threats for cybersecurity, but also new business models, of course, which we need. Yes, next slide, please. So, of course, this is a picture how we could decouple the car. We have, of course, have the hardware, which we need to have to drive the car. And we all have different middlewares and different application. And of course, communication with different aftermarket system, but also databases where we can monetize our data with. So this is, of course, how we should design the software-defined vehicle. We need to remove different layers and put them together back again in a new platform. Yes, next slide. And this is, of course, one slide that are enabling these features on demand. We have now different subscriptions that you need to buy your seat heating, for example, in different of German cars going forward. But you also can buy acceleration increase, etc. And this is, of course, a big part made by software updates, by remote services, and of course these also increase different threats for the cars going forward. Yes, next slide. And as you probably know, a lot of out there, the automotive industry is in Europe and US is facing a lot of different new competitors out there, which have been showing themselves a really good competition out there. But we need to help our current customers with closing the software gap, but also focus on cost and speed. And this, adding with new cybersecurity regulation, etc., will be hard, but this is something we have to do as a whole industry. Yes, next slide. So, summarizing, the software-defined vehicle, it's not about just adding remote services or over-the-air updates. It's not just having more software in the vehicles. It should be the right software in individual vehicles for individual customer. So the software-defined vehicle is a concept that we use for innovation, software innovation. We use it to decouple software and hardware. We use it for understanding the customer, the ownership, the collaboration with different suppliers. We also need to change our mindset, how we develop a car. We also need to change our mindset when it comes to business models. And this is it's a concept more than a product, I think. So yes, next slide. And for us as Diadrom, we are, of course, expert in diagnostics, and this will play a critical role going forward. We need to help our customers to increase the efficiency of their software development. We also, of course, need to help them increase safety regarding their software. We also help them with different operational stuff like minimizing cost, reusing software, and of course, last but I think it might be the most important, we need to secure that our customers having a secure vehicle and a good experience when they're driving their car. Yes, next slide, thanks. So what have we learned today? Key drivers, as we said before, it's a lot of new regulations going out there, both from the UN, but also from the ISO community. We have also learned that cybersecurity is here to stay, of course, due to a lot of new different services, which are mostly remote. We also learned that this is just not for the greater good, but it also adds complexity and costs when we are using the new cybersecurity regulation and standards. And we learned that, of course, software is more than an enabler. It defines the whole industry going forward. Yes, next slide.
And the next slide, that's questions. And if you have any questions, you can write them in the comments up to the right. But I have a question, Victor. I know that you are traveling a lot in the automotive industry. You attend trade shows, you participate in panel debates, you are a keynote speaker, and you meet many, many interesting people in the automotive industry. What else beside automotive security is being discussed in the automotive industry now? What's the interesting topics?
Of course, the big topic I've been to, like embedded world, etc., big trade fairs for software, electronics, and the big buzzword, of course, is the software-defined vehicle. The big discussions out there is, okay, what is a software-defined vehicle? How should we handle it? How should we make it more user-friendly? How should we make money of the car going forward? But as I said before, it's more of a mindset, how to make more money as OEM, but also improving the services and the experience from the customer. So, and not just adding a lot of software into the cars. We need to add the right software, the right function to the right car and the owner, and therefore we will have a better experience for the end customer.
But Diadrom is not the largest company in the automotive industry, where the most companies are very, very, very large. What are the advantages and disadvantages of being a relatively small company and in a large automotive industry?
Of course, being a small player has its disadvantages, of course. Might be a longer way to build a trust and confidence in our services and our knowledge. But I would say that we are trying to be a more friendly, more humble partner to play with. A lot of the big players are having their business model and how they've done business for years. We tend to have a more customer-centric approach, how we handle the projects, and act like more like partners, I would say, just not throwing the software to the customer and then, vanish. But we tend to have a more customer-friendly partnership approach. I think that's our main competitive edge.
And if you are interested in more knowledge and inspiration about software diagnostics, auto tech, and of course cybersecurity, we are going to, as I said earlier, email the presentation and the recording to you. We are also going to email our diagnostic book and a white paper. And if you want, you can subscribe to our newsletter. There we are sharing our knowledge. And another tips is to follow Victor at LinkedIn, because I know he's very active and try to be interesting and relevant at LinkedIn. And you can follow Diadrom as well. And we have 1 minute left. Is there anything else you would like to discuss that we haven't talked about, Victor? You have 1 minute.
Yeah, I think one point is quite crucial in this area. As I said before, there will be a lot of maintenance and, of course, trying to maintain the software throughout the 15 years going forward. I think that's a discussion or topic which we haven't had until now when people are facing this issue. They will, of course, add much of costs and much of people to have these processes. And I also like to send to everyone that all the software libraries, all the open source stuff has a lot of things in it, and we need to be really careful because there are a lot of doors opening up to hackers in these kind of software libraries and open source projects.
Okay, we have one question here. What do we know about the user experience from drivers using different cars, Volvo, Audi, Mercedes, etc.? It's a question in the comments. Can you see it?
Yes, thank you, Bo. The user experience, do you think the interact and it, of course, there are a lot of regarding user experience. Hopefully I answer it right. We have, for example, Mercedes are developing their own MB.OS. We have other people like Polestar, Volvo Cars going for the Google automotive stuff. We see from our customers that they are not sure which way to go. We had another customers of our, Lotus, who made their own user experience interface, and that was a super messy project, which they are now trying to evaluate how they should go forward. Is it a differentiation? Do you want to send all your data to Google, or do you want to keep it by yourself and maintain the system? That's the big question, and of course it relates to cost and competence. But of course, if you find a user experience, an OS operation system that works for you, and you have it done by yourself, I think that's a really good thing to have. But I'm not sure if the OEMs are ready for that yet.
Okay, if there are any more questions, feel free to contact Victor. Do you have any last word before we say bye-bye?
Hopefully I answered Bo's question there, but you can send me an email, Bo, if I was answering the wrong question.
Okay,
Great.
time is up. Thank you very much.
Yes, thank you. Bye-bye.